All right, hello boys and girls. So today we are going to be working on finding the greatest common factor between two numbers, 12 and 20. So, greatest common factor. Remember, when we did this, we used two methods. We used the rainbow method and we also used the factor tree. For today's lesson, we are only going to be focusing on the factor tree. So, to start with, I write my numbers 12 and 30. Then I need to factor them, so we have to make our tree. So I have to think, what two numbers can I multiply together that get to 12? Now, you could have thought of 4 times 3, or you could have done 6 times 2. Either one is a good way to start. For today's video, I'm going to start with 4 times 3. Now, when we do 4 times 3, I have to look, are either one of these prime? And remember, prime means the only way to get to that number when multiplying is 1 times that number. So for example, is 1 times 4 the only way to get to 4? I don't think so, because 2 times 2 also equals 4. So I know 4 is not prime. Let's check out 3. 1 times 3 is the only way to get to 3. Yep, so I'm going to circle that prime number. Now because 4 is not prime, I have to break it down. So like I said before, 2 times 2 equals 4. And if you're thinking of your multiplication facts, the only way to get to 2 when multiplying is 1 times 2. So we know that 2 is also prime. All right, let's do a 30. 30, what times what equals 30? Well, there's a couple options we could start with. We could start with 2 times 15, 3 times 10, or 5 times 6. I'm going to start with 3 times 10. Now, it's okay if you start with 2 times 15 or 5 times 6. Those are both perfect multiples of 30 as well. Now, if we're looking at 3 and 10, I know 3 is prime because I circled it in 12. So again, 3 is prime because 1 times 3 is the only way to get to 3. 10 is not prime because 10 can, when we multiply, we can also multiply 5 times 2 to get 10. Now, of 5 and 2, both of them are prime because the only way to get to them is 1 times that number itself. And now if you notice, I am done with my factor, with my trees, because I'm left with only circled numbers at the end. Now, here comes the tricky part. I need to find a number that is circled underneath 12 that is also circled underneath 30. And if I look, I see that I have a 3 in both of these. So what I'm going to do is I'm going to cross the 3's out because I have a pair, and I'm going to rewrite it. Now, if this was the only number that they had in common, 3 would be my greatest common factor. But let's double check. Underneath 12, I have some 2's, and underneath 30, I have a 5 and a 2. Well, I at least have 1, 2 in each of them. So again, I'm going to cross the 2's out because they make a pair, and I'm going to rewrite that number. Now, my answer is not 32. Okay? Remember, when you cross out a number, you rewrite it. But when you write multiples, you have to put a multiplication sign between it. Now, if you notice, I have a 2 left on the 12 side and a 5 left on the 30 side, and nothing else. Those are not pairs, and we don't have a 5 on the 12 side or a 2 on the 30 side to even make a pair for them. So these are the only two numbers that they have in common, 12 and 30, when we do the factor tree. Now, to find our greatest common factor, we just multiply them. 2 times 3 is 6. So the greatest common factor that 12 and 30 have in common would be 6. Now that we reviewed how to find the greatest common factor, we are going to review how to find equivalent fractions. So over here, I have my starting fraction of 3/4. Now, this week, we learned how to use a giant 1. And we talked about how whenever you multiply anything by 1, it will always equal that original number. So here's my giant 1. And I could pick any number to multiply 3/4 by in the whole entire world. I could multiply by 2, by 3, by 4, by 1,000, by 1,000,000. I could multiply it by 5.5, 10.9, 9.99999. As long as I multiply both the numerator, which is our top number, and my denominator, which is my bottom number, by that same number, I will always have an equivalent fraction. So let's start easy. Let's start with 2. If I want to multiply 3/4 by 2, I have to put a 2 in my giant 1, both in the numerator and denominator, because 2 out of 2 will always equal 1. Now it's really easy. Now we just multiply our numerators together and get an answer, and we multiply our denominators together to get an answer. So my new fraction for my numerator, 3 times 2 is 6, and my denominator, 4 times 2 is 8. So 6/8 is also equal to 3/4. All right, let's try another one. So I start with my fraction I was given, 3/4. I write my giant 1. And sometimes when we draw a giant 1, I'll show you in the next problem how it can look different, because sometimes drawing a 1 like that is pretty challenging. Now let's say I want to take it up a notch and I want to multiply 3/4 by 10. I would put 10 over 10 in my giant 1. Notice how the numerator and denominator are both the same in my giant 1. Again, just like up here, I multiplied my numerators together. So 10 times 3 gets me 30. And then I multiply my denominators. 4 times 10 gets me 40. So 30 over 40 is also equivalent to 3/4. All right, let's do one more. Let's do 3/4. And instead of drawing a giant 1, I'm just going to draw a rectangle. So sometimes in math, I also draw a rectangle like this, because sometimes drawing a giant 1, I'm not good at, and I'm not artistic, but I try my best. So let's multiply 3/4 by, I don't know, let's do 6. So if I want to multiply it by 6 in my giant 1, my numerator and denominator have to be 6. Now, what I said before, you can multiply by any number. That is true. However, you don't want to multiply by 0, because 0 times any number will just get us 0. So we can't multiply by 0. And we also can't multiply by 1, because if I multiply by 1, I'm just back to 3/4. So those two are the only two numbers that would not work, whole integers besides negative numbers, that would not work to find equivalent fractions for 3/4. So I like to start with numbers that are like 2, 3, 4, 5, 6, little numbers that are easy to multiply by. I also like to do tens, because really all you're doing is adding a 0 in your numerator and denominator then. All right, let's solve this last problem right here. 3/4 times our giant 1 of 6. So again, multiply my numerators together. So 3 times 6 is 18. And then look at my denominators, multiply them together. So 4 times 6 is 24. And this right here is also an equivalent fraction to 3/4. All right, I hope these two videos helped you guys review. Make it a great day.